Till now, we understood about free fall, and that near the surface of the earth, the acceleration due to gravity is equal to 10, and it's denoted by A. The acceleration due to gravity is denoted by A, right? And we saw experimentally that the value of G is close to 9.8. Of course, we didn't get the exact value. It was because of some experimental setup, some mess up that I have done. Now, let's actually calculate the value of G with our theoretical understanding. See, one advice is try to understand a topic in as many perspectives as possible. That's the whole idea of me trying to do a particular topic in so many different ways, right? There's so many different approaches towards understanding a topic. Okay, so how do you start off answering such a question? First is, let's consider an object of mass m0 near the surface of the earth. So how does this look? Well, if we have to talk about the free body diagram, we are looking at this. We have an object, and if I take down as positive direction, right, we have a force acting downward, and that is because of acceleration due to gravity, right guys? Acceleration due to gravity. Okay, done. So initial condition is 0 meter per second, and for the time t is equal to 0 seconds. This would be a free body diagram. Next thing, well, we have to recall two things. As per Newton's second law, what does the second law tell? The force that is exerted by this gravity should be equal to whatever it may be. It should be equal to the mass, or in general, force is equal to mass into acceleration. Here the force is F gravity. So if for this particular case, this will be so, and m0, the mass of the object, and acceleration due to gravity. This would be your equation 1. Right guys? Next, as per universal law of gravity. Universal law of gravity. What does he tell? Or he or she tells this, that force between two objects is given by G, capital M, small m by d square. Here F is F gravity, right? That is the force on this particular object. Okay, let me draw it. So this is the object, and say this is the earth, right guys? Just near the surface of the earth, not too far, near the surface of the earth. So that is your m0, and this is earth's mass. And from the center to almost this point, what is that we're looking at? We are looking at the radius of the earth, right guys? So what happens to all of these values? Let me show you guys that. Let me write our statement so that things are clear and you guys are not confused over here. So here m is mass of earth. We'll denote that with me, and we have d, or let me write small m, is mass of object, denoted by mo. T is, since we are looking at as the object is, just, I'll continue over here, just above the surface of the earth, right guys? So it's equal to RE, radius of the earth, right? It's equal to radius of earth, say denoted by RE. Okay, so all of it you need to substitute in. Therefore F of gravity will be equal to Ge mass of the earth, mass of the object divided by radius square. Okay, so we can equate equation 1 and 2 because they are the same thing. They are pointing to the same force. Can you see that? 1, same thing, the LH is the same, and it's equal to m naught g, and this 2 is equated to the same thing. So we'll move on to the next step. From 1 and 2, what can we tell? We have g m naught is equal to capital G me into mo by re square. Is there something common? Yes, m naught and m naught gets cancelled, and g is equal to G capital Me by re square. Can you see something important over here? The value of acceleration due to gravity is just dependent on the radius and the mass of the earth, and the mass of the object is not seen. What does that mean? It's an important, very important conclusion, and it's a fun fact. I would want you guys to web search this. Okay, there is a particular video that you will get. Please do watch it. It's really fun. The acceleration exerted by an object is independent of its mass. This means that all object, hollow or solid, big or small, should fall at the same rate. Let me put it in this way. The video which I'm asking has a bowling ball and a feather, right, in a vacuum chamber. When let go, okay guys, it will fall at the same rate, literally at the same rate, like it's like a still picture. They fall at the same rate even after 5 seconds. Actually it won't be 5 seconds, but it's slowed down a bit. So after 2-3 seconds, you can see that they are on the same level. Generally when you throw a rock and a feather, what happens? The feather takes something like this, it, because of the wind and air and all of that, it takes that path, while the ball just falls straight down. But in vacuum, this does not happen. What does it tell? In case of absence of air in a particular place, any given object, right, and another object, heavy or light or whatever it might be, an elephant and an ant, for example, they will fall at the same rate. Okay, they'll reach the ground at the same time. Let me put it this way. Okay, you can literally touch this. If you say you have a tank and you're falling down with a tank. Okay, so you guys have a tank. Why is the tank falling down with you guys? That's a story which you guys can make up. You can remember this, I guess. So you have a tank and say it's dropped in a vacuum along with you guys. Again, why is it dropped? That's a story you guys can make up. Okay, that's a bad diagram, but anyways, that's supposed to be a suit. It's not a great suit. Okay, you guys are scared. Anyways, so if this two, you are dropped with a tank, you guys can literally touch it if you're next to it. That is, you can literally touch it throughout the journey. I mean, even though you're not in touch, you're not in contact, right? Even after 2-3 seconds after the fall, even then you can touch it. What does that mean? Everything falls at the same rate. Everything will reach the ground at the same time, in the absence of the air, that is. It's a very important conclusion. Okay guys, so acceleration due to gravity on the surface of the earth is given by G me by re square. On the surface of the moon, this equation will turn out to, on moon, G on the moon, acceleration due to gravity on the moon, surface of the moon is G is G. This is of moon, mass of the moon, divided by radius of the moon square. And you can change this to anything, mass, Mars, whatever you guys want it to be. Make sense? Understood? So this is important for you guys to note down. Right guys, so see to that you learn it in an organized manner. Okay, so please pause and please do copy this. In the next video, we'll calculate by substituting the values what is the acceleration due to gravity on the surface of the earth, moon, Mars, whatever you guys want it to be. I'll think of few scenarios and will record that. Okay, so please pause. I hope I made it easy, and do copy this.